I'm just going to walk all of you through each problem on this study guide. So if you only need help on a couple questions, just go ahead and fast forward until that number. I am going to go in chronological order. So if I look at the very first question, I have two radicals that I'm dividing. In order to so I can't have a radical in the denominator, so I have to rationalize the denominator. So in order to rationalize the denominator, I multiply by the denominator. So I'm going to multiply the top by rad 7 and the bottom by rad 7. So I have the square root of 42 over rad 7 and rad 7 just make rad 49, which just makes 7. Before you circle this as your answer, you got to make sure you can't simplify 42. The only factors of 42 are 6 and 7, and then I have 3 and 2, none of which are perfect squares. So my answer is just the square root of 42 divided by 7. If I look at number 2, I have a negative square root, so that means it's going to be an imaginary number, so that negative I can yank out and make I rad 50, and now I have to simplify 50. So simplify 50 is 25 and 2, so the square root of 25 is 5, so 5i, square root of 2 I can't do, so I'm done. If I look at number 3, I'm going to distribute, so I have 6i squared minus 4i. So when you're dealing with imaginary numbers, you have to remember that I squared, I cubed, and I to the 4th pattern, because you can never leave an exponent on an imaginary number. If you leave an exponent on an imaginary number, it's going to be wrong, so you need to be careful. So I is just I squared is negative 1, I cubed is negative I, and I to the 4th is 1. So some good test-taking strategies is when you take your test, you immediately write these patterns down on your test so you don't forget it. So if I come back over here to this problem, I see I squared. Well, I squared is negative 1, so I'm just going to cross it out and make it negative. So now I have negative 6 minus 4i. Remember, your answer has to be in standard form. Standard form is when your real number comes first and then your imaginary comes behind. If I look at number 4, I'm going to double distribute or FOIL, depending which word you like. So 4 times 3 is 12, and 4 times negative 2i is negative 8i. And then I have negative I times 3 is negative 3i. And negative I times negative 2i squared is positive, negative I times negative 2i is positive 2i squared. Whenever I see I squared, I know it means negative 1, so I just cross it out and I just change that sign. So now I have 12 minus 8i minus 3i minus 2. I usually don't write that step when I'm showing my work because I did it up here, but I'm just doing it to help you. So now I'm going to combine like terms. I have 10 minus 11i. So now we're going to go over to number 5. So number 5, I have to distribute 2i, and then over here I have to distribute a negative 1. So I have 6i plus 10i squared minus 4 plus 6i. So I see I squared, I'm going to instantly make it negative, and now I'm just going to clean stuff up. So I always do the real number first, so negative 10 and negative 4 make negative 14, and then I have 6i and 6i, which make 12i, and I'm done. When I'm simplifying imaginary numbers with exponents, you always want to try to find the closest multiple of 4, because if you can find the closest multiple of 4 to that exponent, you know anything I to the 4th power is 1, so then it's just whatever your leftovers are. So the closest multiple of 4 from 33 is 32. So how many is left over after 32 to get to 33? 1. So I know I to the 32 makes 1, so 1 times I to the 1 is just I, so 1 times I is I. If I look at number 7 says I to the 160th power. So 160, well, 4 is a factor of that, so it instantly makes 1, and I'm done. If I go over to the next one, I to the 63rd power, well, I to the 60th is a multiple of 4, so my leftovers are 3. So I to the 60th makes 1, so I'm left with 1 times I cubed, which is just I cubed. And in my pattern that I wrote at the top of my paper, I cubed is negative I. And I'm done. If I look at number 9, so I got to find all multiples of 4. So I to the 32 and I squared makes I to the 34, so 32 is 1, and I squared is negative 1. So now I have to do 150. So 150, so I to the 148, and I squared. I to the 148 is a multiple of 4, so that equals 1. So now I'm left with I squared, which makes negative 1. I to the 99, so I to the 96th is a multiple of 4. And how I knew that was because I knew 4 went into 100. So that means the next closest multiple is if I subtract 4, that's going to be 96. That's how I figured it out without a calculator. So I cubed is left, so that's negative I, but it's already negative. So I have negative I, which is just going to be positive I. And then I have I to the 85th. So I know 88 is a multiple of 4 because 4 goes into 8. So if I subtract 4 from 88, that's 84. So I know 84 is a multiple of 4. And then I'm left with an I, so minus I. So now all I have to do is clean it up. So I have negative 2, and then my i's cancel out, so that's my answer. When you're dividing imaginary numbers, you have to multiply by the conjugate. So the conjugate is just the opposite of the imaginary number. So on this problem, I'm going to multiply by the conjugate. So my conjugate of my denominator would be 5 plus 4i. And I'm going to multiply the bottom by 5 plus 4i as well. And now I just double distribute. So 3 times 5 is 15. 3 times 4i is 12i. 2i times 5 is 10i. And 2i times 4i is 8i squared. And I know I squared makes negative 1, so I'm just going to change that. And now I'm going to clean up the bottom. 5 times 5 is 25. And then I have 20i and negative 20i. And then I have negative 16i squared, which when I cross out the I squared, that makes negative 1, so that's going to be positive 16. So now all I have to do is clean all this stuff up. So I have 15 minus 8, which is 7. And then 12i and 10i make 22i. That's the numerator. And if I clean up the denominator, 25 and 16 make 41, which is a lovely typo on my answer key, but that's okay. But here is the correct answer. And you know you're done because if you circle the coefficients, you can't simplify any of them, so I can move to the next problem. If I look at this next one, when I'm squaring a binomial, I have to write it out. I have to expand it out. 5 minus 6i times 5 minus 6i. So I have 25 minus 30i minus 30i plus 36i squared. I squared makes this negative 1, so negative 36. So 25 minus 36 is negative 11. And then negative 30 and negative 30i make negative 60i. If I look at number 12, Number 12, again, I have to multiply by the conjugate, so it's going to be negative 2 minus I and negative 2 minus I. And now I just double distribute, so I have negative 14 minus 7I minus 6I minus 3I squared, which makes negative 1, which will make positive 3. All over 4 plus 2I minus 2I minus I squared, which just makes negative 1, so that's going to be positive 1. So now I'm going to clean all of this stuff up. I have negative 11 minus negative 13I all over 4 plus 1, which is 5, which again, I did a lovely job on my answer key and got incorrect. So those are the correct solutions. Next one's number 12, factor the following completely. So when I factor, the first thing you want to ask yourself is, does it have a GCF? So it does not have a GCF, so you can factor in a variety of ways. You can factor by grouping, you can factor the X method, you can factor slide and divide, or you can factor while you try to think about it in your head. So I'm going to factor it while thinking about it in my head. So because this is 3x squared, I know this has to be 3x and this has to be x. So now I know my last term has to be a multiple of 20. So I can do 5 and 4, I can do 2 and 10, I can do 20 and 1. So I'm going to try 5 and 4. I'm going to put 5 here and I'm going to put 4 here. And I'm going to multiply my double rainbow. I get 12 and 5. So because 3 times 4 is 12 and 5 times 1 is just 5. So 12 and 5, that doesn't make 11. So what if I put 4 here and I put 5 here? 3 times 5 is 15, 15, and then I have 4, 15 and 4, hey, that gets me 11. So now I just got to figure out, okay, well, how do I get 11? 15 has to be negative, and 4 has to be positive. And I'm done. Let's look at the next one. This next one, I'm factoring a cube, which means I have to follow SOPs. So the first thing I'm going to do is I'm going to take the cube root of each of these, so I'm left with x plus 4. So now I'm going to do SOPs. The S in SOPs is you square your first term, so x squared is x squared. The O is the opposite of that sign, so minus. The P is the product of x and 4, so 4x. This P is positive, and this S is the square root of my last term. So my last term, 4 squared, is 16. And I'm done. If I look at my next one, I notice my next one, I don't have a GCF and my middle term is missing. So when your middle term is missing and your last term is minus, it's a difference of squares, which means one's going to be positive and one's going to be negative. And then all you do, ladies and gentlemen, is you just square root those numbers. So the square root of 4x squared is 2x, so it's going to be 2x and 2x. And the square root of 49 is 7, so 7 and 7, and I'm done. This next one, because I have 4 terms, I have to factor by grouping. So I'm going to split up my 4 terms down the middle, and I'm going to find a GCF on that side. My GCF on this side will be x squared. So I'm going to take out an x squared, so I'm left with 2x minus 3. On this side, my GCF is 2, so I'm left with 2x minus 3. You know you did it correct when these parentheses match, which means that's one answer. And then the leftovers are your other answer, x squared plus 2. Next one. This next one looks a little funny because you have multiple variables. So when people come and ask me, I'm going to say, pretend these variables don't exist. Factor it just like you would. So I'm going to have 2x and x, and then I need 2. So if I think about my double rainbow, the only factors of 2 are 2 and 1, and you want to get 5. So I'm going to put 2 here, and I'm going to put 1 here, because 2 times 2 is 4, and 4 and 1 make 5. But you want negative 5, which means they both have to be negative. So now I have to include that y that I just miraculously scribbled out. So x squared is my first term because x and x make x squared. So to get y squared as my last term, I just have to put a y here and a y here. And if I show you by double distributing, 2x squared minus 4xy minus 1xy plus 2y squared. And if I clean this up, 2x squared minus 5xy plus 2y squared, that matches what I got. All right, let's look at number 17. Number 17, it's another one where it SOPs. So I first have to take the cube root of each. So this will be 2x minus 3y. So now I'm going to SOPs it. So square the first term, 4x squared. O is the opposite, so it's going to be plus. P is the product, so 2x times 3y is 6xy. And the other p is positive. And square the s in SOPs, square the last term, 3y squared is 9y squared. And I'm done. Let's look at number 18. Number 18, again, well, first off, I had a typo. That should have been plus 6. And now I'm going to split it up. I got to factor by grouping. So I got to find a GCF on those guys. So 2x squared. So I'm left with x minus 2. And on this side, my GCF is negative 3. So I'm left with x minus 2. So these match. So I know I did it correctly. And on the other one is 2x squared minus 3. And I'm done. 19. 19 is another SOPs problem, but notice 16 is not a perfect cube. So you have to always start with taking out a GCF. So my GCF is 2. So now I'm left with 8y cubed minus 1. And now I can do SOPs. So 2y minus 1. Now SOPs, square, 4y squared, opposite, product is 2y, positive, square the last term. And don't forget your GCF on the outside. Go ahead and flip your paper. These problems, it says solve each of the following equations. You need to know how to complete the square and use the quadratic formula. You may choose how you wish to solve as long as you practice each type. The answer must be in simplest radical form when possible. So all right, so if I look at this first one, I'm going to go ahead and factor it because it looks like since x squared doesn't have a leading coefficient, I know it's probably going to be easy to factor as long as I can factor it. Factors of 56 are negative 7 and negative 8. I have this equal sign, which means I have to split it up. So x equals 7 and x equals 8. And I'm done. If I look at this next one, first thing I have to do is take out a GCF of 4. So I'm left with 2x squared minus 5x minus 3 equals 0. So again, I'm still going to factor it. Why not? If I'm allowed to pick how I want to solve it, I'm going to do it this way. Factors of 3, so I'm going to put 3 here and 1 here. Double rainbow. 3 times 2 is 6. 6 and 1, I can get negative 5 if 6 is negative and 1 is positive. So now I'm going to solve. So I'm going to split up every factor. I have 4 equals 0, which doesn't work. And then I have x equals negative 1/2 and x equals 3. On number 22, I am not going to expand it. I'm just going to square root and solve for x. So I have 4x minus 5 equals plus or minus 8. I'm now going to add 5 to the other side. So, and then divide by 4. So 5 plus 8 is 13 divided by 4 is 13 over 4. That's one answer. 5 minus 8 is negative 3. Divided by 4 is negative 3/4. If I look at the next one, again, my brain instantly sees I don't have to factor this because I don't have an x squared and an x. So I can just instantly subtract 27 from both sides. And then divide by negative 12. So if I divide by negative 27 divided by negative 12, so I'm just going to clean that up first before I do anything else. That's 9 over 4. I'm now going to square root. So x equals plus or minus 3 over 2. If I look at this next one, I think I'm going to have to factor because I have x squared and x. So negative 15x squared plus 3x plus 12 equals 0. So it has a GCF of negative 3, so 5x squared minus x minus 4 equals 0. So now I'm going to try to factor this. It's going to be 5x and x. To get 4, it can be 2 and 2, or it can be 4 and 1. So if we try 2 and 2, 5 times 2 is 10. 10 and 2, that's not going to get me 1. So how about 1 here and 4 here? 5 and 4, yep, that works. I want negative 5 and positive 4. So negative 3 equals 0, that doesn't work. X equals negative 4/5, and x equals 1. If I look at 25, if I think about factoring it, I can't because there's no factors of 2 that's going to make 10. So I'm going to do this by completing the squares. So I'm going to take all my variables on the left and move all my constants to the right. I'm now going to complete the square. Half of negative 10 is negative 5. I'm now going to square it. I'm going to add 25. Because I added 25 on the left, I have to add 25 on the right. So now I'm going to factor the left. X minus 5 squared equals 23. I'm now going to square root both of those. X minus 5 equals plus or minus rad 23. I can't simplify that, so x equals 5 plus or minus rad 23. So now I'm going to look at number 26. So number 26 is a bit of a mess, so I'm going to go ahead and move everything to one side to make it equal 0. So I'm going to subtract 2x squared and get x squared. I'm going to subtract 3x from 6x, and I'm going to get 3x, and I'm going to add 4 to the other side. So if I think about factors of 4 to make positive 3, none of that works, because 4 and negative 1 would work, but then that product would be negative 4. So I'm going to go ahead and, again, I'd rather complete the square than do the quadratic formula, so I'm going to complete the square again. So subtract 4, all right, complete the square. Half of 3 is 3/2, square it, that's 9/4. And then I got to add 9/4 to this side as well. So now I have to factor the right side, x plus 3 over 2 squared, and now I have to clean up this side. So I have to have a denominator of 4. So that's going to be negative 16. So negative 16 plus 9 is negative 7 over 4. So now I'm going to square root that. So notice it's going to be an imaginary number because I have a negative square root. So x plus 3 over 2 equals plus or minus I rad 7 over 2. So now I'm going to subtract 3/2 to the other side. So I have x equals negative 3 plus or minus I rad 7 over 2. And I'm done. Let's go ahead and do the next one. I'm going to subtract x squared to make 2x squared. I'm going to subtract 3x and make negative 4x. And I'm going to add 14 and make 19. All right, I'm going to divide everything. I'm going to do quadratic formula on this one. So I'm going to do 4 plus or minus the square root of 4 squared minus 4 times 2 times 19 all over 4. So now I have 4 plus or minus the square root of 16 minus 4 times 2 is 8 times 19 is 152 all over 4. So now I have 16 minus 152 is negative 136. So I have 4 plus or minus I square root of 136, because I knew it was going to be negative, all over 4. So now I got to try to simplify the square root of 136. So 136 divided by 4 is 34. So 4 and 34. 34 is 17 and 2, so I'm done. So I have 4 plus or minus 2I rad 34 all over 4. So if I simplify that, that's 1/2. So to keep the same denominator, that has to be 2. So I have x equals 2 plus or minus I rad 34 over 2. And my answer key on that guy is wrong too. So I will go ahead and fix those as well. All right, so let's go ahead and do number 28. So I'm going to subtract 12. And I'm going to get negative 8. I'm not going to divide by 2. I'm going to get negative 4. I'm not going to square root negative 4. I am going to get x plus 3 equals plus or minus 2i. I'm not going to subtract 3 on both sides. And I get x equals negative 3 plus or minus 2i. I'm not going to do number 29. Number 29, I'm going to go ahead and do the quadratic formula again. So I'm left with 16 minus 4 times 2 times 3. I got 16 by just squaring in my head, all over 4. So now I have 4 plus or minus 16 minus 4 times 2 is 8 times 3 is 24, all over 4. So now I have 4 plus or minus I, because I know it's going to be negative. 16 minus 24 is 8, all over 4. So I have 4 plus or minus 2I rad 2, because this is 4 and 2, all over 4. And now it's the exact same thing. Now it's going to be 1/2, and to keep the denominator, I have to keep it the same. So it's going to be 2 plus or minus I rad 2, all over 2. All right, so let's keep going. So these ones we have to solve the quadratic inequalities. So in order to solve the quadratic inequalities, we have to make it equal 0. And now we have to factor. So factors of 16 are 8 and 2. To get negative 6, it's going to be negative 8 and positive 2. So now I have x equals 8 and x equals negative 2. So I'm going to go ahead and I'm going to plot on my number line negative 2 and 8. And now remember, I have to test points. So I have to test a value that's less than negative 2. So I'm going to say negative 3. So if I plug in negative 3 here, negative 3 and negative 8, that's going to be a negative number. And if I plug in negative 3 plus 2, that's going to be a negative number. And a negative times a negative is a positive. So now I'm going to pick a number between negative 2 and 8, so 0. If I plug in 0, it's going to be negative, and if I plug in 0, it's going to be positive. So I have negative and I have positive, which will be negative. And if I plug in a number greater than 8, let's pick 9. If I plug in 9 to my first parentheses, that's going to be positive. And if I plug in 9 to my second parentheses, that's going to be positive, which makes positive. So now I want to go and look at my inequality symbol. My inequality symbol is less than, so I know these are going to be open dots, and it's going to be wherever there's a negative. So my interval notation will be negative 2, comma 8. If I do 31, I'm going to make it equal 0 by adding 1 to the other side. So now I have to factor, and I know it's 1 and 1. So to get negative and a positive, they're both negative. So x is 1/5 and x is 1. So now I'm going to plot this on my number line. 1/5, 1. So now I got to pick a number to the left of 1/5. So to the left of 1/5, let's just do 0. If I plug in 0 to my first parenthesis, it's negative. And if I plug in 0 to my second parenthesis, it's negative. So negative and a negative make a positive. If I now pick a number between 1/5 and 1, I'm going to pick 1/2, so 0.5. So if I take half of 5, that's 2.5. So 2.5 minus 1, that's positive. And 1/2 minus 1, that's negative. So I have a positive and a negative, which makes a negative. So now I'm going to plug in 2. If I plug in 2, I have a positive and a positive, which makes a positive. So now I'm going to look at my inequality symbol. It's greater than or equal to, which means these are going to be closed dots. And everywhere there's a greater than sign is where my arrow goes. So my interval notation is negative infinity to 1/5. Staple. Union. Staple. 1 to infinity. If I go ahead and I do this last one, I'm going to move everything to the left. So it'll be 2x squared plus 5x plus 2 is less than or equal to 0. So now I'm going to factor. So factors of 2 are 2 and 1. So add them up. I get 4 and 1, which makes 5. So x equals negative 1/2. X equals negative 2. So negative 2, negative 1/2. Now I'm going to test my values. So if I plug in negative 4, negative 4, that's going to be negative, and that's going to be negative, so positive. But somewhere between negative 2 and negative 1/2, so how about negative 1? So that'll be, this will be negative, and this will be positive, which will make negative. And on the right, the greater than of negative 1/2, we plug in 0. That's positive for my first parenthesis, and positive for my second parenthesis. So now I'm going to look at my inequality symbol. It's equal to, so I know it's closed dots, and it's less than, so I go everywhere where there is the minus sign. So my interval notation is negative 2, comma, negative 1/2. Alright, so now if we look at 33. 33 says use the discriminant to determine the number of solutions each quadratic function has. So the discriminant is b squared minus 4ac. So b squared minus 4ac. You have to have that memorized. So I have 20 squared minus 4 times 5 times 21. So 20 squared is 400. And then I have to do 4 times 5, which is 20, times 21 is negative 420. So now I get negative 20. This is less than 0, which means I have no real solutions, which means I have 2 imaginary solutions. If I come over and do the next one, I would do 5 squared minus 4 times 8 times 1. So I have 25 minus 32. So that's negative 7, which is also less than 0, which means I have no real solutions. If it was greater than 0, I would have 2 real solutions. If it equaled 0, I'd have 1 real solution. So now I'm going to go ahead and I'm going to graph each of these. And I have to graph them, depending on the form, I have to use these specific criteria. So, number 35, this is standard form. So I'm going to first say that it opens up. And now to find the axis of symmetry, I have to do x equals the opposite of b over 2 times a. So I have negative 1 over 1, so x is negative 1. That's my axis of symmetry. So now to find my vertex, that's my x value. So now if I erase this, I'm going to do my work up here. 1/2 times negative 1 squared minus 1 minus 3. So negative 1 squared is 1. 1 times 1/2 is 1/2. So 1 minus 1/2, 1/2 minus 1 is negative 1/2. And then I have negative 1/2 minus 3, which if I make a common denominator, is going to be negative 7 over 2. So that's my vertex. So now zeros, I'm going to imagine I can't factor this because I have a leading coefficient of a fraction. So I'm just going to come back to zeros in a second. But I can definitely do y-intercept. My y-intercept is just 0, -3. So to do my zeros, because it asked me to find the zeros, I'm just going to do the quadratic formula. So -1 plus or minus the square root of 1 squared minus 4 times a times c all over 2 times a. So I have -1 plus or minus 1. 1/2 of 4 is 2. 2 times -3, so that's going to be plus 6 all over 1. So that's -1 plus or minus the square root of 7. So my zeros, if I write it in blue, is -1 plus or minus the square root of 7, comma 0. So can I even graph that? Well, no, I can't because I'm not allowed to use a calculator, but I still know how to find it when the problem asks me to. So now I'm going to go ahead and graph all of this fun stuff. So my axis of symmetry is x equals -1/2. Remember, if you don't include x equals, you're going to lose 1/2 a point. So now I'm going to do -1, -7 over 2, which is -3.5. My y-intercept is -3, so now I can just do the reflection point, and then I'm just going to connect my dots. Let's go to the next one. The next one is in vertex form. So it opens up, and my vertex is 7, -1. So 7, -1. And I have a vertical stretch of 3. So over 1, up 3. Over 1, up 3. And I'm going to just connect my dots. 37. 37 is intercept form. So it opens down because it's negative. My zeros are 4, 0, and -2, 0. My axis of symmetry, I have to add these values and divide by 2. So 4 plus -2 is 2, divided by 2 is 1. So now my vertex is 1, comma, and now I have to find it, so I'm going to plug in 1. So 1 minus 4 is -3, and 1 plus 2 is 3, and then I have a negative, which is going to make 9. And then my y-intercept, I just distribute the last terms of everything. So I get 8. So 0, 8. So now I'm going to plot. So I have x0 is at 4, -2. My axis of symmetry is at 1. My vertex is at 1, 9, which is very nicely going to go off my graph. 8, 9. And my y-intercept is at 8. And this is an inequality, so I'm going to do a dotted line because it's less than. And I'm sorry, it's not less than, it's greater than. And so since it's greater than, I'm going to draw an up arrow. And I notice my up arrow is in between the legs of my parabola, which means I shade in between my parabola. I come over to do 38. 38 is in standard form. So it opens down. To find my axis of symmetry, I will do x equals the opposite of b, so it'll be 1 over 2 times -1, which is 1 over -2, so x is -1/2. So now to find my vertex, that's -1/2. So now I got to plug that in. So -1/2 squared is 1/4, so that's going to be -1/4 plus 1/2, which will be 1/4. My zeros, I have to factor, so I have to take out a negative x, so I'm left with x minus 1. So if I equals 0, so I have x equals 0 and x equals 1. So my zeros will be 0, 0, and 1, 0. And my y-intercept, I'm going to plug 0 into everything. My y-intercept is just c, so 0, 0. So now I'm going to go ahead and graph. My axis of symmetry is -1/2, -1/2, comma 1/4, so that's like right there. My zeros are 0, 0, and 1, 0, and -1, 0. Yes, I messed up down here. That should be a +1, which would make that a -1, which would make that -1, 0. My y-intercept is 0, 0, so I'm going to just draw a solid parabola because it's less than or equal to. Because it's less than, I'm going to put my pencil on my vertex, and I'm going to draw a down arrow. And notice my down arrow is in between my parabolas, so I shade in between my parabola legs. Last page. If I look at number 39, I could say that it was either vertex form or standard form, so it's really whichever form you prefer. I personally think that vertex form is easier. It's less work to write down, so I'm going to say it's vertex form. It's going to open up. My vertex is 0, -3. So 0, -3. It's a vertical stretch of 2, so over 1, up 2, over 1, up 2, over 2, up 8, and over 2, if I can count, 1, 2, 3, 4, 5, 6, 7, 8. It's an equation, so I'm just going to connect my dots, except I did a horrible job connecting my dots. And I'm done. Last one, number 40. This is intercept form. So it's going to open up. My zeros are -2, 0, and 1, 0. I'm just taking the opposite of those. My axis of symmetry, I'm just going to add my x values and divide by 2. So -2 plus 1 is -1. -1 divided by 2 is -1/2. So now my vertex, I have to plug -1/2 in. So 2, -1/2 plus 2, -1/2 minus 1. All right, so -1 plus 2 is 1.5, which is 3/2. And -1 minus 1 is -1.5, which is -3/2. So if I multiply these together first, my 2's cancel out. So now I'm just left with -9 over 2. So my vertex is -1/2, -9 over 2. So now all I got to do is find my y-intercept. So I just take all my numbers in my equation and multiply them together. 2 times 2 is 4, times -1 is -2. So I'm going to plot -2, I'm going to plot 1. My axis of symmetry is at -1/2. My vertex is at -1/2, -9 over 2, which is 4.5. I'm now going to plot my y-intercept, which is at 0, -2. No, it is not at 0, -2. 2 times 2 is 4. So how about at -4? I like messing up this afternoon. That's at -4. I was going to say that parabola doesn't look right. Yep, and then I do my reflection point. Look at my inequality symbol. It's going to be a solid parabola. And it's greater than, so I'm going to draw an up arrow, and I shade where that arrow is. Last but not least, change to standard form. So I'm going to do -2 times x minus 4 times x minus 4 minus -5. So now I got to double distribute. I have x squared minus 8x plus 16. I just did the double rainbow in my head. So now I got to distribute this -2. So I have -2x squared plus 16x minus 32 minus 5. So now I have y equals -2x squared plus 16x minus 37. You want to make sure you include y equals so you don't lose points. If I look at the next one, I want to change it into vertex form. So I'm going to group all my x's together. I'm now going to take out the 2. I'm now going to complete the square. Half of -6 is -3. I'm going to square it. I get 9. So now I have to find what c is. C is really 18. So over here I got to subtract 18. So now I'm going to factor. I have x minus 3 squared minus 15 equals y. On 43, I'm going to factor. I have x minus 6 and x minus 5 equals g of x. So now I'm going to put number 44 in vertex form. So I'm going to group all my x's together. I'm going to take out a 3. I'm now going to complete the square. Half of -3 is -3 over 2. Square it, I get 9 over 4. So to get my c value over here, I have to take 3 times 9 over 4 first. So that's like saying 3 over 1, which is going to make 27 over 4. So that's going to be minus 27 over 4. So now I'm going to factor this side. And now I have to clean this up. So 4 minus 27 over 4. So I have to find a common denominator. So that's going to be 16. So 16 minus 27 is -11 over 4. And this equals y, so I don't lose my point, and I'm done.